Right. So when you open it after installation, you will be seeing this particular screen, and obviously it is a blank canvas currently, and all of the modeling options and toolbars and all the menus, they are not alive or available for you yet unless you start a new model from here. So you can either start from file new model or just click on this particular button here. So starting a new model requires you to essentially perform two activities. First is to select the units of your model in which you will be working, but you can change them at the later stage also. So they will be available at the bottom right of your screen all the time. So you can change them at any stage of the modeling later also. So, but we will be selecting, for example, Newton millimeter here, and then default materials you can select US. Obviously you can change that later also, and there's no uh, binding that you will be using only materials from US, or it's just for the purpose of the standard designation of defining materials, that they will be using US designation or US classification, for example. The second thing you have to do while defining a new model is to select a template. So you can see here that there are a variety of available structural templates from which you can start your model. For example, you can start your model with a three-dimensional frame, or for example, a solid model. SAP 2000 have a solid element also. You can model trusses, two-dimensional and three-dimensional, two-dimensional frames, for example, and other special structures also. So since our example structure for this demonstration is a three-dimensional reinforced concrete building, so we can either start with this 3D frame or we can start with grid only. Most of the times, obviously, since our structure is not matching with any of the available templates, we start with grid only. If we click on grid only for this particular case, it will ask us about the grid lines, their spacing and their number in both in all x, y and z directions. So it will create a three-dimensional grid space or grid lines in which using which we can actually draw or model our structure. So if I select any other template, for example, go to again that same view and select, for example, three-dimensional frame, it will ask me some basic properties of that frame, and when I click OK, for example, number of stories and x and y direction base and their spacings and story height, uh, and when I click OK, it will simply create that structure using that limited information which we have provided. But obviously in this demonstration we will be simply starting with a new grid. So I'll be selecting grid only. And now if I go back and see my example structures plan view, in X direction, the horizontal direction in plan view, I must have at 1, 2, 3, 4, 5, 6 lines, 6 lines in X direction, like this axis, and then I must have 1, 2, 3 and 4 lines along Y axis. So uh, 6 and 4 lines I must have in both x and y directions respectively. So I will say here in x direction I'll type 6, a number of grid lines. In y direction I say 4, and in z direction, since it is a 10-story building, so z direction is the vertical axis in SAP. So I'll be using actually uh, the 11 lines in z direction, which will actually be used to draw those or model those 10 stories. In x direction, the spacing actually is between lines is given already here, that we have 5 spans which is 8 meters apart, and similarly on in y direction we have 3 spans and they again are 8 meters apart. So actually the spacing in x and y direction is same, which is 8 meters. So I'll be just changing this 6,000 millimeters to 8,000. The story height is constant, which is 3 meters, and that is here. So 3 meter story height I'll be simply using here also 3. And the first grid line location should start from 0, which is the default origin of this global coordinate system, which is a rectangular or Cartesian coordinate system. For cylindrical kind of structures, you can also define a cylindrical uh, Cartesian coordinate system, but here we will be simply using these uh, rectilinear grid lines here. So I'll be just clicking OK, and therefore the program actually uh, define the grids for me. So when you define a grid system, it will by default open two different views of the same model on your canvas. On the left hand side, you will be seeing the XY plane, which is the plan view. XY plane is actually the plan view of your grid system here. And here on the right hand side, when you click on this view, it will be available, and you can see here that it is a three-dimensional view. So these are the uh, default view options here which you can use to change these views. For example, if while selecting a three-dimensional view, I can set it to XY view and it will convert to that. Similarly, XZ and YZ are the two elevation views in two directions of the building. So it is always convenient to model and work with two different views, because whatever change you perform in, for example, a plan view, it will also be shown in real time in your three-dimensional view, so you can check it in both views at the same time. So plan view actually can, since this building is a 10-story building, is actually going to be a 10-story building, so it will be having 10 plans. So whichever plan is selected currently or view here, it will be shown here by this Z axis. So currently this is the XY plane at the rate of you can say Z equal to 30,000. So it is the uh, topmost XY plane which you are currently seeing, and you can also confirm that by looking at this cyan line, blue line, which is surrounding the plan top plan actually. When I click on this left hand side, you can say left hand side view. So if I, let's say, click on this button, which will take me move down in the list, so now you can see that the cyan line on three-dimensional view actually it is only appearing when my mouse is in the XY plane. So you can see that the cyan line is now not the topmost but one level down. So I can toggle between different plan views. You can see here it is going down and then finally going up again. So it is really important to know that at which XY plane you are when you are modeling your structure in the plan view. Similarly, if I click on this XY plane view and goes to, let's say, XZ, XZ will mean that I am looking at this particular uh, elevation of the structure. So if I click on now the XZ, it is showing me the particular frame with the cyan blue color. It is enclosing that you are currently looking at that particular frame view or elevation view. So I can again click on forward or backward or up or down buttons to move between different you can say uh, elevation views of the same structure. So again, obviously, if I would like to draw columns or shear walls, I will be using this particular elevation view for this frame, and I'll move between different frames using this up and down buttons. Similarly, if I click on this XZ plane again and go to the YZ view, I'll be actually seeing from this side. I'm seeing the structure from this particular side. So again, I can use up and down button, and the cyan color uh, that cyan color rectangle is moving along different elevation views, right? So please keep on noting that cyan color to just verify that you are, whatever you are doing it in a correct elevation view or correct frame view, right? So again, clicking on this left window and then go to again the XY, which means that you are in the plan view. So that's how you move or navigate between different views. You can also click on this three-dimensional view and also modify it whatever view you want. Sometimes people are more comfortable with having more than one views at the same time. For example, you can always click on this small arrow and add a new window here, and that third window, for example this one, can again be changed to another view, for example an elevation view, right? So you can always use these buttons to toggle between different views, right? So currently let's just keep only the three-dimensional view and close the other view which we have just created, and this is our plan view on the left hand side. With this information, if you go back to my typical workflow flowchart, this one, so we have actually performed this step, starting a new model in which we have selected the units, and then we have also selected a template which requires us, in this case, setting up the grid lines. If we have selected any other template, we have to provide its properties and it will directly create the model. The next step in the same workflow would be to define materials which will be used in our structure. Obviously, we will be inputting the material properties, and then those materials will be called in the section properties. So we will be defining cross sections, and we will be essentially providing the cross sectional dimensions, and then those cross sections will be called in the elements, which means when we draw the elements, we have to select a cross section. When we define a cross section, we have to select a particular material and associate that material with that cross section. So this is the sequence which we'll be following to create that particular model. So let me now go back again to the program window, and uh, you can use this edit and view option. They are mostly the self-explanatory options. Once you have already created some geometry and you want to modify it, you can go to this edit option, and many of the modification options for points, lines and areas and solids, they will be available here. I'll maybe demonstrate at a later stage. And view options have all those view things which are mostly self-explanatory. So the real fun actually starts from define menu, where the first option is the materials. So I'll be just clicking on define materials here, and these are the two default materials which you can actually see here. But obviously we will be defining a new material, so I add a new material. So you can just select a region. Obviously this will not affect your uh, analysis results. It is just asking you to get the default characterization or classification of materials. So it will be a concrete material type, and I can just make it a user defined material, not a particular standard grade. And obviously these grades will depend on what what option for region you have selected or what material type you have selected. So I'll be just clicking on user and click OK. So this form will appear, which will take from me those four basic input properties which are used in the analysis, and a few design properties also. For example, the most important one is the 28-day compressive strength, which is the represented here as the F prime C. So let me just give this concrete some name. It can be, because in my structure we have uh, just one type of concrete, which is this one, having a 27.5 megapascal concrete FC prime and this much uh, modulus of elasticity. So I'll be just calling it concrete, for example 27.5 megapascal. I'll just quickly do it because uh, in this short time maybe I can just quickly demonstrate, and then you can do practice later on. So I can just type some notes or associated grade which will be used later at some stage, not in analysis but in design. I have to provide the weight per unit volume, which should be used later on to calculate the seismic weight of the structure, and then also the mass matrix will be using that weight. Elastic modulus, I should provide the Poisson's ratio, the coefficient of thermal expansion, and the shear modulus is automatically calculated from elastic modulus and the Poisson's ratio. This is the concrete strength I should provide here. So maybe 27.5, both expected and specified. Expected strength generally is higher than the nominal FC prime, but for analysis none of these properties will be used. These are the analysis properties. If you use the same model to run the design after the analysis, then these FC prime is of use. You have seen that the global stiffness matrix of the structure is not dependent on material strengths. If the structure is elastic, it only depends on the stiffness of materials, or in actual the elastic modulus and Poisson ratio and the associated properties. So I'll be simply clicking OK, and this will define my elastic material uh, for the purpose of linear analysis. Similarly, I'll define a new material, but this time it will be of steel type. So it should be, obviously you have to select a particular standard. The standard for structural steel is different, and standard for the steel rebar is different. So you have to select a particular uh, classification. Maybe I can use, I can select region as user, and then no standard classification will be shown here. And then I go to give it some name, maybe my rebars, and it should be 420 megapascal. So please check when you are filling that form that your units are correct. They are you are inputting values in the correct units. So I can say rebars, and the Fy of those rebars is 413 megapascal here, or Newton per millimeter square. So I can say here it's 413 MPa, right? And then the elastic modulus was actually 200 gigapascal. It's almost same, but if you want you can change that number. Poisson's ratio, the other same four properties, as well as the unit weight. This is the properties used for design. So this is Fy, which should be actually 413, and Fu should be according to this 620 megapascal. So I'll be simply uh, inputting this 620. Do we have a question up till now? Right, right. So again, the expected yield strength is higher. There are different standards which guide us that how much higher the expected value should be for steel compared to nominal value. Generally, it is assumed that the expected value is 15 to 20% higher than the yield value. But since we are using only for this model for the purpose of structural analysis and not for structural design, therefore no matter what value we give, it will not be used for analysis here. So again I repeat that only these four properties will be used for structural analysis, and for the purpose of mass matrix and the seismic weight calculation, you will be using the program will be using the unit weight which we have provided here. So I'll just click OK, and this will be my rebars and my concrete defined. So the material definition is done. I click OK. So this first step is completed if you are following the linear elastic modeling. So I again go back to the same overview. So now we have defined materials. The next step should be to define cross-sectional properties and call those materials in those cross sections. So for example, for beams, column, shear walls and slabs, I'll be defining cross sections, and while defining those cross sections, I will associate a particular material with them. So let me just quickly show you the process, and then because I want to directly go to the load part and then analysis and then show you some results. So let me just quickly complete that process. So section properties, I'll go and then go to frame sections. This is the second option in the define menu, and I add a new property. I can select rectangular because my concrete and concrete beams and columns have a rectangular cross section. So I'll select the base material as concrete, and in them I can select rectangle, and then I give the name of the cross section. For example, this is my beams, and then give the depth as well as width. You can see here the cross section dimensions were for our structure were directly given. It is having a 375 by 500, and then columns and shear wall and slab thicknesses are also given. So I'll be just filling that form and associating a material with that particular cross section. For example, this one is 375, 500 is the depth in millimeters, and then 375 is the width. And then you can see that if, for example, I click OK and then OK, you can see at the bottom right, these are the units which you can change at any time during the analysis. If you change them, all your input values will be converted to the new units. Currently they are Newton millimeter, so whatever number I input in program in this particular setting will be considered in these units, right? So I go again back to define and then section, frame sections, and this is the section I just defined. I modify it, modify show properties, and this is the section I just defined, the depth and width. But also you have to define the, you have to associate that cross section with a material, so you will do it here. So this is actually composed of my concrete, which is 27.5 megapascal. So this is the number which the material which I just defined. So I selected that one, and then property modifiers is also an important parameter which you have to define if you are performing the analysis for the purpose of code-based structural design. So different codes actually provide you a set of cracked stiffness modifiers which actually uh, used to account for the cracked stiffness of your beams and columns and shear walls and slabs. So you have to provide those crack stiffness modifiers here. For example, if you are following ACI 318, it prescribes that the flexural stiffness of your beams uh, should be modified by a factor of 0.35. So actually you will be providing that factor in the bending stiffness options, which is moment of inertia about 2 and 3 axis, which are the local axis of your cross section. For this particular beam, since the bending will be primarily about the 3 axis, so you should essentially provide that factor of 0.35 in this particular moment of inertia about 3 axis. But generally, since the bending in some complex geometries and shapes can occur, some part of the bending can also occur about 2 axis, so generally people give a 0.35 factor for both 2 and 3 axis. But you should keep in mind that the primary bending for this particular beam will be about 3 axis, and therefore this number should be modified with 0.35 if you are following, for example, ACI 318. Different other building codes prescribed a slightly different modifier for different elements. You have to follow a particular building code for that purpose. Similarly, concrete reinforcement option is also there, where you can define the design type and select the material associated with your longitudinal bars and your transverse reinforcement confinement bars. But obviously this option will be used for the purpose of structural design, and it doesn't have any effect on your analysis output. So you can just keep it as it is, or if you want, you can give some trial reinforcement or the starting, preliminary reinforcement, but obviously it won't affect your analysis results. So I'll just click OK now, and this is how I'll define a beam section. Then I can also define a column cross section. So I can add a new property, again the same rectangle, give for example 375 by 375. This is my column cross sectional property. I can give it some name, for example columns, and then you can again same associate a material with that, for example this one, concrete, this one, and then modifiers also. For this case, now the modifier will be 0.75, and the column can bend about both 2 and 3 axes, and therefore we will be providing the 0.75 or 0.7, whatever code prescribed crack stiffness modifier you are using from a particular building code, you can provide it here. And then if you want, you can see what are those sectional properties automatically determined by the program. uh, and you can see here that these are just by giving this depth and width, the program was able to calculate a list of all cross-sectional properties. You can check them and use them if you want. So, and I'll just click OK. For columns also, again, if you want to perform some design feature also, you can go in this view and give some starting reinforcement. Uh, while designing a particular column, if you want an automated design for columns, they have this program have an additional option whether that reinforcement which you have provided should be checked, it's enough or not, or adequate or not adequate, or it can be designed also, which means the program will give its reinforcement output as the design output. So, but I'll not be going into detail of design options here, so I'll click OK. So columns will also be defined like that. These are the two different frame sections, and you can define as many number of frame sections which you have in your structure. I'll just quickly go to the area sections now, in which I'll be defining my slab and shear wall cross sections. So I'll start with the simple shell element and add a new section, give it some name, for example shear wall. And again you have six different options or types of shell elements depending upon the consideration of shear deformations. We have thin shell formulation and a thick shell formulation. uh, you can see, you can, I think, search more details about these two different mathematical formulations for uh, in different finite element courses, and also in the analysis reference manual, the technical manual which comes with SAP 2000. Mostly the thin and thick shell, the difference is in the consideration of shear, how the shear is treated in that mathematical formulation of shell. So you can check what is the difference between um, Kirchhoff and Mendlin formulation for shell element. Then you can also model your shear wall as plate element. Plate is mostly associated, or is an element which should be used only for out of plane bending, membrane used for in plane actions, but shell actually combine both plane and in plane and out of plane degrees of freedom. So it is always good to use shell if you are not sure. Finally, you also have a nonlinear shell element in SAP 2000, which is called layer shell element. But since we are performing an elastic modeling, so I'll be simply going into using the thin shell formulation for that. Here I have to provide the bending and membrane thicknesses. Since shell element can model both the in plane or membrane action as well as the out of plane or bending action, so we have to provide thickness for both actions, which will be obviously same. 250 for our structure, I think it is same. Yeah, the shear wall is 250 millimeters, so I'll be using this number. I have to associate a particular material with this shear wall, which is concrete 27.5 megapascal, and then all other advanced options I'll just skip and then click OK. Again, obviously the stiffness modifier you should use for shear walls, and again it depends on what building code you are using and for what actions it prescribes the use of crack stiffness modifiers. So I click OK, and then again go the same process, and this time I define a slab which has a thickness of 200 millimeter. So 200 here and then 200 here, and then again thin shell, and then I'll be using concrete 27.5 megapascal, and then click modifiers also I have to provide and click OK. So and then I click OK, and now my definition of cross sections is complete. uh, I will be sharing the complete model with you also, and you can check some specific details which I am currently skipping because of the shortage of time, but you can always check that model and practice yourself to familiar yourself with these options. So after definition of materials, the next step was materials and cross sections. The next step was the actual definition of elements. So it was here, yes. So I have to draw elements now to complete the geometry, right? So I'll just quickly show you some of the uh, drawing options, and then you can later explore to complete this structure. I'll not be able to introduce you to all of the drawing or you can say drafting options available in this program, but you can explore this menu later on, all of these options. Most of these options are also available on this toolbar on the left hand side. So you can see on the left hand side, these are the drawing options available, and you can expand them later on by clicking on this small arrow. And these are the selection and snapping options. So all of this whole toolbar is for drawing your structure. It is very similar to what you have in AutoCAD or any other drafting environment for the purpose of computer aided analysis or design. So let me start with, for example, drawing the beams of this top floor, which is currently the plan view, and Z equal to 30,000, also shown by the cyan uh, box on the three-dimensional view. You can see here on the top there is a cyan color showing that currently my plan view or the current view is the topmost floor. So I will click on, for example, this option, draw frame cable, which means this option can be used to draw a frame element, which means beams, columns for our case. So when I click on this particular button, this additional box appear, which I can just move anywhere on the screen. And in that box, I have to essentially select one thing which is most important, and you can see others also. This is the cross section. So this will show the list of all cross sections which we have defined while define cross section and frame elements. So these are the two frame elements cross sections which we have just defined. So I will select beams. This is the section which I defined. But please explore other options also. They have specific purpose. But for this quick demonstration, I'll just focus on this one input, which is the selection of the cross section. So after this selection, I go back to my plan view, and now you can see that these are the snapping options. My mouse can snap at the intersections of different grid lines. So I left click on one end, and then you can see that now the drawing process started already. My mouse is changed, the symbol is changed, and I click on the other end of the beam, and it is created and shown here by the blue color. If I move this small box to a bit other side, so you can see here that the same blue color beam is also shown on three-dimensional view on the right side view. Similarly, I can keep on clicking different uh, grid intersections to keep on drawing that uh, beams. And if I right click at a particular location, this option will just end. I mean, the continuous beam drawing option will end, but I am still in that drawing mode shown by the cursor symbol, unless I again click on this arrow button, and now I go out of that drawing mode, right? So please play with these options later on, how you can draw or create geometry of your structure using these grid lines. There is also a quick draw frame option also, which means that you can simply drag a box, and all of the grid intersections, they will be connected by beam element or whatever cross section which you select from here. So I select beams again, and this time I draw a box around all of these grid lines, and you can see here that the program automatically draw the beam elements. I can again do it for these elements, sorry, like this. I think I should enclose all of them in order to use this option. So shown by the rectangular box, dotted box around this option. So maybe I can quickly complete this by using again the first option. So I am left clicking the two ends and then right click to go out of that drawing mode. Again left clicking the two ends, right click, left click, and similarly I complete all the beams of uh, this particular plan view. Similarly for columns, I will be going to an elevation view. For example, I click here on this canvas and then I go to XZ view. So this is my elevation view, and for this particular example I can, for example, select this quick draw option, and this time I select the column cross section which I defined earlier, and then drag all the grid lines, enclose them in a rectangle uh, in which I want to draw a column. So it draw different column elements between in along these grid lines. Similarly, I can draw it like this. Similarly, like this, and that's how I can draw different column elements. But obviously for your real structure, different column elements will have different cross sections, so you cannot quickly do it as I am doing. You have to select different cross sectional properties here and then select those columns and all that. So that's how you will be drawing the frame elements and complete your whole structure. For shear wall and slab elements, these are the area element options available. Again, you have two options. One is that you can click on different points to actually draw it, and other is the quick draw, in which you can just click in between a particular grid line, and then it can just draw it, the rectangular panel. So let me just click on this arrow button here. Let's say that I want to draw a shear wall, all the shear wall panels in this particular span. So I can use either this option, draw rectangle, and then the cross section should be, let's say, shear wall, which I just defined, and I can left click on this and drag it up till the bottom end, and then it will, and click left click again. So that's how it create this shear wall element. You can see here. Obviously you can click on it again, go to uh, options and colors to change its display color using this option. So here currently my shear wall uh, is shown by this particular uh, color. Maybe I can change it. You can click on, let's say, this, and then change the color also. Maybe I use this option, and similarly this was one edge, but maybe some other edge also you can go and display. Maybe this also you use a red color, for example, and then again, because for each shell element you have different faces, so you can change it all faces. So this is the fill face, this one, maybe this one also, and this one also red color. So, and the edge may also be red color, so all of it can be red color. So you can see here now the edges are red color. This is, you can click on it and it will show you a red color. If you want an extruded view of this three-dimensional view or any plan view or elevation view, you can click on that view and click on this tick option, and in that these are the options, display options, which you can modify or click or uncheck or check. In general options, there is an option called extrude in view type. So if you can click on that and then fill objects, maybe you can apply it. So you can see the actual extruded view of your model. And here you can see the shear wall, one element which you have just defined. So I can quickly do things in this elevation view. For example, I can click on it, and then after that I can use this quick draw option. In this option I can select a cross section and simply click on the areas in between, and it will keep on drawing the areas, right, this, right. So that's how I can quickly create any shear wall, for example. Similarly for slab, I should go into the plan view. I click that arrow again, click on the view, and then go to XY view, and in that again you can see with the cyan color that I am on the top floor, and I again click on this quick draw area. This time I select the slab uh, section property, and then I just click in between in between the spans, and it is quickly drawing me the slab elements. So I can complete this, let's say, one floor quickly. So that's how you will be completing your all slabs, and if they have different thicknesses, you have to select a different cross section for different floor levels, etc., etc. So you can complete the geometry uh, in this manner. Now, one important thing is that if you realize that you have to add an additional element for which you do not have a grid line, and you want to add different grid lines for complex shapes and geometries. For example, for this particular plan view, we have a C-shaped core wall in the middle, and we don't have a grid line for drawing actually that C-shaped wall. So we can always add those grid lines by right clicking and then edit grid data, and this is the same global axis which we have defined at the start of this model. So I can modify that global axis, and this view will give me an option to add or modify the existing grid lines or delete a particular grid line, for example. So I can always add grid lines in X and Y. That will be my plan view to draw new elements or things which doesn't fall on a particular intersection of a grid line, for example. So for example, here in X direction, I can add a grid line in between grid C and D. Maybe its ordinate will be in that particular X direction, will be in between 16,000 and 24,000. So let me add another line and make it or modify it to 20,000, let's say, in between two existing grid lines. So you can see here that there is a additional grid line by the name G is added. Similarly, in the Y grid data, I can add a new grid line. Y grid IDs are 1, 2, 3, 4, and now fifth is added. If I want to make it, let's say, again 20,000 in Y direction, it will be in between grid 3 and grid 4. Similarly, in the Z direction also, if you want to model an additional story or a multi or any other uh, element in the additional elevation or in between two existing elevations, you can add a Z grid data. So I click OK now and see these changes here. You can see here that these additional two grid lines, one number 5 and one G grid line in these two directions are added. So now you have an additional grid point intersection and you can draw things. So always you have to use this option, because in the start of the project you will simply lay out your overall or predominating grid spacing, but later on you have to adjust and modify and add new grids in order to create a real structural geometry. So you start with an overall spacing, but then you always need to edit that grid data using right click and then this edit grid data options. You can always see other options when you click on this existing global coordinate system. You can hide all grid lines by clicking on this, and if you click OK, the grid lines will be hidden from your structure, both from the plan view as well as three-dimensional view, and you can always modify again and then uncheck that option. One additional thing is that if your structure is an irregular structure and irregular shaped plan view, and it is following, let's say, two different grid lines, one along the horizontal and vertical directions and one maybe in the diagonal direction, you can always add a new grid system also and set its own origin, and you can rotate it also and get some other things. So you can always have a you can say a different kind of grid system, name it differently, and then you will have grid lines along that along uh, that grid system also. So you will have two types of grid lines, one corresponding to one global grid system and one corresponding to the one you have defined. So that's how I think you will complete the geometry. And let me go back again to the workflow and see whether we are ready to define the loads or not.